Good day and welcome to another video. In today's video, we will be going over the mathematics June control test for grade 9. We will be going over the Gauteng province's paper from 2023. Okay, the total marks was 75 marks and you had to complete the paper within 1.5 hours. Let's look at the first question. First question is multiple choice. We needed to choose the correct answer from the possible outcomes. The following mathematical statement is provided. We have 3p plus negative 3p equals to 0. We have the four properties there, which of the property this one is. There's additive inverse, multiplicative inverse, commutative property of addition, associative property of addition. So immediately we're looking at 1.1, we can look at A, the additive inverse, meaning that you're adding the inverse of something. So the inverse of 3p is negative 3p, so I'm adding negative 3p and that equals to 0. My additive inverse will always equal to 0. Yes, if I add z plus, and my additive inverse for z plus would be z plus negative z. Okay, let's have a look at 1.2. 1.1's answer is A. Let's have a look at 1.2. The lowest common multiple of 24, 30, and 36 using prime factorization is. Okay, so we have to now start with using prime factorization for 24, 30, and 36. So let's have a look at 24, 30, and 36. So we're just going to do a factor 3 over there. We should know how to do a factor 3. This is just a revision test. We divide 24 by 2, we get 12. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 3 is 1. These are our prime factors. So we know when we do LCM, we need to write our numbers as a product of its prime factors. We do the same with 30. We have 2, 15. We cannot divide 15 by 2, so we're going to try 3. We divide 15 by 3, we get 5. And then we can only divide 5 by 5. And then we have again our prime factors. So we have 30 equals to 3 times 5. Sorry. It's equal to 2 times 3 times 5. Right, and then for 36, just do that over here. I can divide 36 by 2. I get 18. Divide 18 by 2, I get 9. I can divide 9 by 3, I get 3. And I can divide 3 by 3, I get 1. So then I have 36 equals to 2 times 2 times 3 times 3. I can also rewrite this to be equal to 2 to the power of 3 times 3. 2 times 3 times 5. And then I can also have 2 to the power of 2 times 3 to the power of 2. As we should know by now how to do the LCM, but I'll show it again. We can see that the prime number of 2 is in all three, okay, but we take the one with the highest power. Okay, so the LCM would be, so we're going to take the one with the highest power, which is that over there, so 2 to the power of 3. Then we have 3 and 3 to the power of 2, so you're going to take the highest power, which is 3 to the power of 2. And for LCM, unlike highest common factor, we have a 5 here. We don't have 5 anywhere else. Now, in highest common factor, we would not consider that 5, but in LCM, we consider all the prime numbers or the prime factors that are in over here. Okay, so there's no other 5, so we just take the 5 as is. Okay, so that's our LCM. Now again, we can get an answer for that, but as we can see, the multiple choice options read as follows. So if we look at the multiple choice options, we can see 2 to the power of 3 times 3 to the power of 2 times 5. So the answer for 1.2 is D. Let's have a look at 1.3. Now, something very important we need to note when it comes to exponents, anything that has an exponent of 0, okay, is equal to 1. So 5 to the power of 0 is equal to 1. 10 to the power of 0 is equal to 1. And what you do need to note in this case here is that the 0 is outside of a bracket. That meaning everything inside the bracket, the 0 applies to. So regardless of what is inside the bracket, everything inside the bracket will equal to 1, simply because of that exponent of 0 which is outside of the bracket. So the answer for 1.3 is C. Now I've got patterns for 1.4. The following pattern is formed using bricks. We have pattern 1, 2, 3. The number of bricks in pattern 4 is. Okay, so in pattern 1 we have 1 brick, then in pattern 2 we have 4 bricks, then in pattern 3 we have 7 bricks. What I can see here is that from this pattern to the next, 3 is being added, and I can also see that 3 is constantly being added. So that means the fourth pattern, I would simply add 3, 7 plus 3, that means that answer would be 10. So 1.4 is B. Oh, 1.5, simplify. Now we need to simplify minus 5x minus 4y plus 8x minus 2y. So the first thing we'll look for when it comes to, this is what we see as an algebraic expression. The first thing we look for is like terms. Now I can identify that this is a like term with that. So I'm going to first write that next to each other. I mean, you could solve this in one go, but I'm going to take it step by step. Then we have minus 4y minus 2y. So we have minus 5x plus 8x, that's equal to 3x, minus 4y minus 2y is equal to minus 6y. Okay, and we cannot go further because these are not like terms. So the answer for 1.5 is B. Alright, question 2, starting off with the topic whole numbers. A fruit farmer has apple trees, orange trees, and peach trees in the ratio 2, 3, and 5. If there are 1,500 trees in total on the farm, how many of each type of fruit tree does the farmer have? Now, we look at the ratio 2, 3, and 5. The first thing we do is identify the 2, the 3, and the 5. The 2 we have is apple trees. The 3 is our orange. And our 5 peach trees. Now we have a total of what? 1,500 trees. So the first thing we do when we have a ratio, and we are going to divide this ratio to find out how many trees of each type of fruit, we're going to add 2 plus 3, 2 plus 3 plus 5, that's equal to 10. So now that's the total. That's very important. So now my apple tree is going to be 2 over the total times 1,500. Okay, this is for our apple. Okay, so 2 over 10 times 1,500. So the number of apple trees here is 300 apple trees. We're going to do the same for our orange and our peach. So for our orange, we're going to say 3 over 10 because that ratio is for the orange there, times 1,500. 450, this is our orange trees. And now, simply for our pitch, we're going to say 5 over 10 times 1500, and that's equal to 750. That is our pitch trees. It's important that we label each of these as we go along in answering your question in the exam. Okay, so let's have a look at 2.1.2. It takes 4 people 12 hours to pick fruit on the farm. How long would it take 6 people? It's very important to understand this question very carefully. Now, if 4 people takes 12 hours, remember that in the application now, the more people, less hours needs to be taken. So I'm going to look for 6 people, right? And I'm going to figure this out. Now, 4 people, 12 hours. So I want to know how many hours would it take one person. It's very important not to divide this for now. If 4 people takes 12 hours, I want to know how many hours that each person, or will it take for one person. What I will do here, I will say 4 multiply by 12. I am simply multiplying 4 by 12 to get my answer of 48. This 48 is the total hours to complete. Okay, so we have 4 times 12 is 48 total hours to complete. Okay, and then to find out how many hours 6 people would take, we have that 48 hours and we're going to divide it by 6. Okay, because we're going to split those hours equally by 6, and then our answer is 8 hours. Okay, alternatively, you could have also had 4 people like this and 12 hours. You could have seen that it's also even numbers. So you could have also said, okay, if 4 people takes 12 hours, I can say 2 people will take 24 hours. Okay, because if I half the number of people, I double the hours. Very important. Less people, more working time for you. Okay, so in other words, okay, I divide it by 2 here to get for 2 people, and then I multiply on the side. Okay, now remember I'm still working with 6 people. So to get to 6 people, if I'm going to multiply by 3 on the side for 6 people, then here what do I have to do? Is now the opposite of that, is divide by 3. So then 24 divided by 3, that is equal to 8 hours. There are a lot of ways to do this one, but it's very important to understand the more people, the less hours it takes. In question 2.1.2, an example of indirect or direct proportion. Okay, I'm just going to give you this one. Okay, indirect proportion means as one quantity is increasing, another quantity is decreasing. Direct proportion means both quantities or scenarios are either both increasing or both decreasing. In this case, more people, less hours. So people increase, hours decrease. So that means that this is indirect proportion, because as the number of people increases, the time to complete the work decreases. Let's have a look at question 2.2. The farmer's son wants to buy a new phone for 15,500 but does not have any money. Okay, so he has 2 options. He can borrow the money from his father, who will lend him the money at 12.5% per annum, simple interest for 2 years. That's option A. Then option B, he can borrow money from his mom, who will lend him money at 12% per annum, compound interest for 2 years. Now, some of you already can tell, okay, mom, really, you are charging me compound interest um, at the same interest rate, same number of years. I already can tell who I'm going to pay more. So yeah, but now we have to use calculations to support our answer and then indicate which option is the better option. Now, you know that simple interest and compound interest each has their own formula. So let's start with the father with the simple interest formula of A is equal to P1 plus I dot N. Okay, so we know that P is the principal amount, so it is 15,500. Okay, brackets 1 plus that 12,5, we know it goes over 100, that's the percentage, and we multiply that with N, which is 2 years. And it's quite simple, we just plug that into the formula, into our calculator as well. Then we get the answer of 19,375. Okay, this is, we have to what, pay what? For the father. Okay, we are going into the compounds territory, but that is what we have to pay to the father back after borrowing 15,500. We have to pay back 19,000, which I would think, okay, it's around about reasonable. Okay, then compound interest, which is your mom. Okay, very important to indicate. I've seen a lot of learners not indicating what the calculations are for or who the calculations are for. We know that we have a compound interest formula as well. We have A is equal to P, 1 plus I, and then the N is the exponent. Again, same values fortunately for us. So our principal amount, which is 15,500, brackets, 1 plus again 12,5 over 100. And that is an exponent to the power of 2. We substitute that into the formula, we get an answer of 19,617, comma 19. Okay, so this is, you have two options, your mother, your father, and you can clearly see who you'll be paying more back. So you have to indicate a option A is cheaper. Most of us lose this mark. Not indicating this would be losing a mark. Alright, let's have a look at question 3, which is integers. Tabo was asked by his teacher to find the answer for minus 3 added to 4. Tabo's answer is shown below. Now let us check. Oh, you're checking your little brother's work. His name is Tabo. Is Tabo's answer correct? Use calculations to support your answer. And looking at that straight, some of us can see that Tabo, it's not on the right track. So a few things we need to note about this equation. Okay, so let us first check this. Tabo's answer was -1, but let's just erase that to check it out. We know that when a plus sign is outside of a bracket, a plus and a minus, that still makes a minus. So we have 4 minus 3. 4 minus 3 is equal to 1, positive 1. So we state Tabo is incorrect. Let's have a look at 3.2. Simplify the following. Show all your calculations. It's very important that we don't simply put this into our calculator. Okay, we have to show each step. We don't have only get to the final answer. We need to show these brackets, how they went away, and have all the signs. So we have minus 36 plus sign outside of a bracket there, plus minus, that makes minus 15. That's just working out the signs. Now it's important to note that between the 3 and the bracket, that's multiplication because there's no sign in between there. So this is minus 3 multiplied by minus 2. Minus multiplied by a minus is positive. 3 times 2 is 6. Those are 2 marks evaluating those 2 brackets. So let's not waste that. Then we have minus 36 minus 15. We're going to do this separately. Minus 36, that's 40, 51. That's minus 51 plus 6. And minus 51 plus 6. That's equal to minus 45. Okay. Okay, let's have a look at question 4. State whether the following statement is true or whether it is false. In a question like this, don't waste your time. It didn't say show calculations, so you go straight. I can show you how to do this without a calculator. You can simply put this straight into your calculator and see if you get this state true or false. Same with this. Okay. However, you want to learn, you want to know how, you want to know why. I will show you. Now, we have a negative exponent. When we have a negative exponent, whatever's inside the bracket becomes a denominator. So it becomes minus 4, sorry, 1 over 4 squared. That 2 now goes to the bottom with the 4. It becomes to the denominator. Okay? And then it still stays squared. And then we have 1 over 4 squared, which is 1 over 16. So false. Okay? It is not equal to negative 16. Even the sign alone would give it away. In any case, over here, now we have minus 4 squared. Is it equal to 1 over 16? You can probably tell that it's not. Because what does this mean? It means minus 4 times minus 4. That's what this means. It duplicates twice whatever's inside the bracket, multiply it by itself. 2 times. Minus 4 times minus 4. It is positive. 4 times 4. 16. Which is not that. Again, both is false. Okay, simplify the following, show a calculation. And now we need to show everything. Now, the cube root of a fraction. When you have a cube root of a fraction, it's important to note that our understanding of cube roots, we can do the following. We have a fraction, so we can find the cube root of the top over the cube root of the denominator. Plus we'll carry on later. There's a negative exponent again. Soon as you see negative exponent, it goes to the denominator over there. Okay, that's just an exponent law. You should have learned, but it's fine if you are learning it now. The cube root of 64 you need to find, and the cube root of 512 you need to find. But I can guarantee you, without a calculator, most of you probably won't find it. It's unrealistic. Okay, not unrealistic, but for anyways. So the cube root of 64, okay, you can put that into your you can put this into your calculator and this into your calculator separately. Okay, you can work it out separately via showing all your calculations. So the cube root of 64, you should know that to be 4. If you don't, just put it into your calculator. You won't lose any marks, but don't put the entire thing. You can put just this one. Okay, same here, 512. Yeah, it's 8. Then plus 1 over 4 to the power of 3 is 4 times 4 times 4, which is 64. Okay, now we have nice addition of fractions over here. We look for the LCM between 8 and 64. Okay, now 64 is a multiple of 8. Okay, so I already know that I'm going to have 64 in there. So our LCM always goes to the bottom. Then we ask ourselves, how many times does 8 go into 64? It goes in 8 times. Then we multiply the 8 times the 4. So that is equal to 32. I'm not mistaken. 64 goes into 64 1 times. 1 times 1 is 1. Then we have 33 over 64. Okay, I did do a video on adding fractions, you can check that out, but I'm not going to go over that again. Okay, you can just skip to that video quickly and come back. Okay, so here we have some square roots, cube roots, and squares, all of it involving exponents. So I have a number outside of a square root. I know that it's being multiplied. Okay, so it's 2 times whatever this is, and the square root of 49, we know that to be 7, so it's 2 times 7 there. Just evaluating that. Do not put this entire thing into your calculator. We work individually. We bring it down. Cube root of 125 is 5. 5 times 5 times 5 is equal to 125. We have minus 5 squared. This is telling us minus 5 times minus 5, and we know that that's going to be a positive 25. Then this is minus and a plus. We know a minus and a plus simply makes a minus. So that's step 2. Then step 3, we have 2 times 7, which is 14, plus 5 minus 25. So we have 14 plus 5, which is 19 minus 25. Okay, and as you can see, each step I'm delicately doing to ensure that I get all my marks. And 19 minus 25 is equal to negative 6. Alright, let's have a look at question 5. Numeric and geometric patterns. The pattern below is made using squares. Study the pattern and answer the questions that follow. Determine the general term or rule to calculate the number of squares in each figure. Now, let's just take a moment to breathe. Determine the general term or rule. Now, when we are determining the general term or rule, we know that Tn is equal to dn plus c. Okay, in whatever way you could find a general term, you can find it in your own unique way. Okay, but I like to work with okay. So we have Tn equals to dn plus c, which is what we're going to use to help us to find the general term. So firstly, d, you can say Tn, the difference. Okay, we look at 1, 2, and 3. We see that it's 4, then it is 5, then it is 6. That what I'm referring to is the number of squares in each figure. So the difference is 1. So then I now have Tn equals to n plus c. It's 1n, but I'm just going to write n. Next I need to find c. Okay, now I can ask myself, the first term, n is referring to the position. So 1 is the position. So if I have 4 spaces in the first term, what do I have to do to get to the 4 spaces? I have to add 3. Okay, so now I know that I have to add 3. Okay, so I have Tn equals to n plus 3. That is my general term. Now I have the question, how many squares will figure 22 have? Now, each figure, we know that if it's the first figure, it's the first figure plus 3. The second figure, we know that the number of spaces is 2 plus 3. For the third figure, the number of spaces is 3 plus 3. So that is telling us that T22, okay, which is the 22nd pattern, they want to know how many spaces. I'm going to say 22 plus 3. So that means there will be 25 spaces. Okay. Now we want to know which figure will be made up of 203 squares. So we know that the Tn represents the number of squares, the spaces, and this represents the figure So for example, if it's the first figure, it's 1 plus 3, which is equal to 4, and this is the spaces. Okay, so we're looking at 203 spaces equal to n plus 3. N being our figure, we don't know which figure it is. Right, and then to solve for that, we're simply going to take the 3 over, and we have 200 equals to n being figure 200. Figure 200 will have 203 spaces. You see, you can verify that by just adding the 3 to the figure. 5.2.1 says determine the values of A, B, and C. Now, we have to study the diagram below, and we need to understand what is happening in this diagram. So, what's actually happening, I'm going to start off with the first row as a quick example. So what's actually happening is that this x goes in there. So this x, which is x, goes in there. So what actually happens is 2, it is being substituted in there. That minus 2 is being substituted in there within brackets minus 1. So that's the input. So we have then 2, that is 4 minus 1, that is 8 minus 1. Interesting. Oh, sorry. This is actually not 8, this is A. I was about to say. So then 8 minus 1 is equal to 7. Okay, so then this is actually saying that A is equal to 7, because what I put in here, I put it in that place and I get it out there. So that A should be 7 after I substituted the negative 2 into the row. Okay, right? Then for B, similarly now, I put the B in X's place. So if you should be comfortable working with letters by now. So we're going to say 2 brackets b brackets squared minus 1. I put b in, I must get negative 1 as my output or as my answer. This one is a bit more difficult. It's reverse. I have to now solve for b. Now I have 2 b squared. I'm going to take the 1 over minus 1. Sorry, minus 1 plus 1 minus plus 1 minus 1 plus 1 is equal to 0. Okay, now to solve for b, I divide this both sides by 2. So I have b squared equal to 0. And then to find b, I square root both sides. B is equal to 0. For c, the same thing now. Okay, so for c, we have 2c squared, okay, brackets, minus 1, that's equal to 7. So we're solving for c again, same process. We take the 1 over, so it's 7 plus 1. The squared goes to the c. So we have 2c squared equals to 8. To solve for c, I first have to divide by the 2 on both sides. So I have c squared equals to 4. Okay, and now it's important to note when I square root, I always have two answers, the negative and the positive. So c is equal to plus minus 2. Okay, it's important to note there. Don't get confused by this now. Okay, c is equal to plus 2, but it can also equal to minus 2. Okay, so we have studied the table below. Write the general term for the pattern in the form y is equal to. So we have input and we have our output values. We have our input minus 2, output is minus 4. Then we have minus 1 input, minus 3 output. So our input is minus 2, then we get to minus 4. What happened in that process to go from minus 2 to minus 4? So you can say y is equal to, okay, it goes from minus 2, okay, and then it goes to minus 4. What happened there? We know that y, okay, is going to be equal to x minus 2. Why did I get that? Whatever my x value was, which is my input, I minus the 2 to get to my output. That is why I have minus 2 there. So this is what they mean. Now we need to determine the values a. Okay, so we have our y, which is equal to minus 2, right? And then a was our input there. So a is the x minus 2. I take the 2 over, minus 2 plus 2 equals to a. A is equal to 0. Okay, and then in the case with b is the output. So y being the output, b is the output. So I can have b is equal to, so we have 4, which is my input, x, as we can see from the table, minus 2, which we always do, and then b is equal to 2. Question 6, algebraic expressions. James is currently 6 years old and his sister Ellie is half his age. How old is Ellie? How old will Ellie be when James celebrates his 50th birthday? So James is currently 6. Let's write it down. James is now currently 6 years. We say that Ellie is half his age currently. So 6 divided by 2, that is 3 years. So currently Ellie is 3 years, James is 6 years. So James is 3 plus years and Ellie is minus 3 years. He's 3 years younger, James is 3 years older. That's the maths. It's making it look complicated. Okay, but what all you need to know is that James is 6 years old, Ellie is half of that, and Ellie is 3 years old currently. But when James celebrates his 50th, we know that Ellie will be 3 years younger. So 50 minus 3 is equal to 47. So that will be Ellie's age when James turns 50. Okay, we need to simplify the following. So let's have a look at this one over here. It's quite simple. Okay, we have this, it stays like that. Now we have a number or term outside of a bracket. We know what we should be doing there. We're going to multiply it in. So we have 3x squared plus, that is equal to 2x squared minus 6x. Multiply that 2 in there. And then we still have the minus 4x squared, the plus 6x. Now we're looking for our like terms. We know that it has to be the exact same letter and the exact same exponent. So like term, like term, like term, put them together or next to each other. We have 3x squared plus 2x squared minus 4x squared. Then we can see minus 6x plus 6x is like terms. Let's do this one first. These like terms first. So 3x squared plus 2x squared is 5x squared minus 4x squared is equal to 1x squared. Okay. Then minus 6x plus 6x is 0. You could say plus 0 there, but you could have also said, alternatively, you could have said 1x squared plus 0. I know some of you will have that as an answer, but that is correct and this is correct as well. Let's have a look at the second one. We have a fraction, but when you have a fraction, you start at the numerator. You don't have to do everything at the same time or be overwhelmed by the question. Okay, so we start at the top. We can see, okay, there's a term outside of a bracket. Let's multiply. You know that. So let's do that first. 3x, okay, multiplied by 8x is equal to 24x squared. Then 3x multiplied by minus 12, that is equal to negative. That's 36x. Remember the x also multiplies. I know some of you will forget that. Minus 24x over 12x. Again, at the top, we're still working there. We still see like terms. So 24x squared minus 24x squared is equal to 0. Thank goodness for that. So we have minus 36 over minus 36x over 12x. Now we have a simple fraction. When you have something like this, those x's will cancel. Minus 36 divided by 12, it's a negative number divided by a positive number. So we still have negative as an answer there. So 36 divided by 12, that's equal to 3. So the final answer is equal to negative 3. Fully factorized. I know this word is a nightmare in grade 9 when you are first introduced to it. But yeah, we have to do it. So when we fully factorize, we first look at the common factor. Are there any common factors here between the letters and the numbers? Yes, 2, 4, and 6. The common factor here is 2. We have 2 as a common factor. We make brackets. 2 divided by 2 here. So we just left with the x plus the 2 divided by the 4y. We left with 2y. And the 2 divided by the 6 is minus 3z. That's it. Yeah. Now let's just fix this. This is 7c. Okay, so we have 4 brackets 7c minus d plus a, this is not 9. That's a brackets d minus 7c. Now we see the type of factorization we can do is common brackets, but there's a problem with our common brackets. Is that inside the second bracket here, the signs are different. This is a negative d, that's a positive d. That's a positive 7c, that's a negative 7c. So you should have learned to take out a negative. What that means, I can change these two signs. I can change it. Both of them I can change. I have to change. If I change one of them, I have to change both of them. And if I change both of them, the consequence of that will be that whatever is outside, sign must change. So I have 4, 7c minus d. I want to change this. I want to make this a positive 7c and that a negative d. Why am I doing that again? To have the common brackets. And if I do change these signs, remember firstly, I must change both. And then secondly, because I changed the sign, something else must be affected. Is this a outside? The a will become negative. Okay? If this was negative, it would have become positive. Now that I have common brackets, I just simply put 7c minus d 4 minus a. Now I have a trinomial over here. I can already tell it's a trinomial looking at the 3 terms. However, before I do my trinomial, I start with looking if there's a common factor for me to take out. I can see even numbers. I can see the common factor is 2. So I take 2 out. 2 divided by 2 is just 1x squared. Minus 10 divided by 2 is minus 5x. And minus 28 divided by 2 is minus 14. Now again, this is a trinomial. I did common factor. I get my marks for taking out the common factor there. Then I need to factorize this little buddy over here, which is a trinomial. Now, there are many ways to do this. Many infinite ways. Not infinite, but there's a lot of other ways to do this. Okay, so I look at my factors of 14. I can either take 14 and 1 as my factors. What else is there? 7 and 2. But the relationship that I choose must relate with the middle term. So 14 and 1 doesn't go anywhere near a 5. So 7 and 2, oh, if I take 7 and 2, and somewhere there is minus or addition, I can get to 5. So I choose 7 and 2 there, and I choose x here and x here. I know most of you will not be familiar with this method. Whatever method suits you for the trinomials, you can do that. Now I have to choose signs. This is a negative 14. 7 times 2, it must equal to negative. Now, One of these must be negative, one of these must be positive. Why again? Because this is negative 14 here. Yeah? Again, you're probably confused. So this is minus 5. So I'm going to make the minus 7 or the 7 negative and the 2 positive, because minus 7 plus 2, minus 7x plus 2x is minus 5x. So then I have two brackets, x minus 7, x plus 2. Okay. 6.4 says determine the value of a minus b squared minus a plus b squared if a is minus 1 and b is 6. Now this one is simple. All you do, you take these letters, numbers, you substitute it in. Simple. To have minus 1 minus 6. Okay. Normally put brackets, but I'm not going to put brackets. It's not necessary. Squared minus minus 1 plus 6. All I did was I substituted a, this value, b, that value in there. So first I have to evaluate the brackets. That's minus 7 squared minus, that's 5 squared. Minus 7 squared is equal to 49 minus, that's equal to 25. So I have 49 minus 25, that's equal to 24. Question 7, solving equations. X squared minus 25. Now, sometimes factorization will be involved, and I can see difference of squares there. Okay, or let's take the easy route. X squared equals to 25. Then I square root both sides, and I have x equals to, remember now, whenever you square root something, the answer is not just 5, it is plus 5 and minus 5. Okay, I'm not going to do the factorizing, I'm going to ease off on that. Now, the zero factor law, if you do know the zero factor law, when you have two brackets like this next to each other and it equals to 0, one of these brackets must equal 0. You know that anything times 0 is equal to what? 0. So firstly, I'm going to state, when you see something like this, you should be familiar. You say x plus 7 equals to 0, or x minus 4 equals to 0. Okay, you solve here, you say x equals to minus 7 because you take it over, and you say, or you take the minus 4 over, you say x equals to 4. Okay, whenever you have two brackets like this next to each other, one of them you can solve, and the other one you can solve by letting them separately equal to 0. Now, 7.1.3, we have 7x over 2 equals to x minus 5. Now, we have divide by 2 there. So, firstly, we do not want any denominators. So, to get rid of it, we're going to multiply it by 2. But when you do that, you multiply every single term by 2. It's a rule. So that 2 there will cancel. You have 7x equals to 2x minus 10. Okay? Because 2 times x is 2x, 2 times 5 is minus 10. Solving for x would be 7x minus 2x equals to minus 10. 5x equals to minus 10. Let's go over there. So we have 5x minus, 5x equals to minus 10. To find x, we divide by the number that's next to x. So we have x equals to minus 10 divided by 5 is equal to minus 2. Minus number divided by positive number is still minus. 10 divided by 5 is 2. Okay. Now, here again we have something tricky. We have 3x plus 2. When you have an exponent in grade 9 for now, you have an exponent of a letter, take everything else over to the other side. So 14 minus 5, so we have 3, x plus 2, that's equals to 9. The next step you do is, when you have this, you rewrite to have the same basis. So you're going to rewrite this 9 to have the base of 3 to the power of 2. Okay, because 3 is squared. is 9. Okay, this only happens now when our unknown is in the exponent form, and then we take everything else over, we get an answer. Then whatever the base is where our exponent is a letter, we must get whatever's on the right hand side. Like I have 9, I need to try to get it also to have a base of 3. Okay, so 9, I can rewrite it to have a base of 3, but 9 is equal to 3 squared. Just to note that out there. Once I have now equal bases, I can say x plus 2 equals to 2. I can then equal my exponents. So then I can solve for this. Take the 2 over. Okay. 2, take the 2 over, it becomes minus 2. That 2 is now minus 2 there. 2 minus 2. Ah, and that's it.